Welcome to everybody who's starting to join. We'll get started here in about 3 or 4 minutes. So thank you for attending and be along shortly. Yeah, welcome everybody. Looks like we've got a pretty good group joining. I'll give everybody another moment or two and then we'll start pretty promptly. So call this a 1-minute warning and then we'll get rolling. All right, everybody, welcome again, and let's go ahead and get started. So my name is Josh Brothheim. I'm going to be today's trainer, and I am a training manager at Sumo Logic. So if you've done our Sumo Logic trainings before, you might have heard my voice or one of my peers. But what we're going to be doing today is AWS Observability, and specifically how we can utilize tracing and Root Cause Explorer to help with that. And so let's talk about the agenda. If there's any questions for today's session, go ahead and put them in the chat. I'll answer them periodically. And so here's our agenda. We'll stick to it pretty closely, give or take. And so we're going to do an introduction, kind of started that already, so that's already underway. We're going to talk a little bit about end-to-end observability. Then we're going to talk about AWS observability and how the two are related, and I'm sure you know the connection. And then start to talk about RCE, which is that root cause explorer, talk about tracing, talk about some other features as well. This slide should probably be updated because we'll talk about service maps, a bunch of features within Sumo. And we'll be doing some hands-on labs. So I don't have it defined in here specifically. We will jump into this system 2 or 3 times today to, like I said, do some labs. And so we have some training accounts that we'll give to you later for that. Yeah, away we go. So Sumo Logic, and specifically the continuous intelligence platform that we have, or sometimes we refer to it as SIP. What are we? Who are we? Not meant to be a sales pitch by any means, but basically just want to introduce ourselves if you're not familiar. So Sumo Logic, continuous intelligence platform, gives you the ability to start to analyze or use analytics across your operations, your security, your business, your global intelligence data, kind of everything you see on the top row. Now, there's more than just those 4 dashboards, but that's a good kind of overview. And so we can assist you with that operational intelligence and help you understand what systems are up and running. What is your MTTI and MTTR, those metrics that become more and more important every day. With the security intelligence, helping you identify what users are logging into root access. Is a user logging in multiple times? Should they be? And things like that. Business intelligence, are people frequently ordering things on your website? Are they viewing things on your website? What are they ordering if they are doing so? And then global intelligence, kind of from a worldwide standpoint. Now, in order for Sumo Logic to assist you, you're going to need to, or we're going to need to, utilize your data. And so using the data-driven intelligence, we can extract real-time insights and business value from massive volumes of machine data generated that might be in the form of everything you see on this row and more. So data coming from your apps, your mobile devices, third-party systems, et cetera, et cetera. All that data comes into Sumo Logic, and then using our analytics, and we're going to look at, sort of look at analytics a little bit today. You can start to utilize things like the APIs, the advanced analytics features. Sumo Logic is multi-tenancy and scalable and elastic. It grows and expands or shrinks down as you need to utilize it. And then fortunately, everybody can benefit from Sumo, not just those people that we see on this list here, but everybody in the organization. Yay, Sumo. So, and then on the far right, we just, as a reminder, we have those security attestations. Actually, I think we're missing a few on here, but that are important to maybe not you, but somebody in your organization probably wants to know that we are FedRAMP compliant or HIPAA compliant, depending on what your side of the house is. All right, so that's just a quick overview of Sumo. Certainly could talk about more, but let's show rather than talk. So wanted to talk about end-to-end observability with Sumo Logic. But first I wanted to just define monitoring versus observability, just so we're all on the same page, because a lot of people equate the two, and they're certainly related, of course, but how are they related? And I guess more importantly, what's the difference? So observability monitoring, when we dig deeper into something, it's not just about seeing when something goes wrong, but what's causing it, what areas it's impacting, how can we correct it before it impacts more customers or more parts of the application. Monitoring is about telling you the state of the system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored, then we're really going to have no idea what's happening there. And knowing something is wrong is important. Observability goes beyond monitoring by taking these logs, metrics, traces, these things we're going to look at in a few moments, to provide us a broader view and a deeper context. Knowing something wrong is important, but maybe more importantly, of being able to find out why it's wrong is really going to be key to your investigation. Observability, let me get that slide. There we go. Observability requires more data and richer analytics as you go from an alert to the problem resolution. And so what I'm attempting to portray here is an iceberg. And the top of it's kind of thin, but as we get to the bottom of it, it gets chunkier, more heavier, and kind of deceiving in that way that icebergs can be. And so what we're trying to show here is the idea of there's going to be 2 requirements for any observability solution, not just Sumo, but any of them. Now, Sumo's going to be able to help with these 2 requirements, but they're going to be important to you. Firstly, the observability solution, whatever it is going to be or is currently, needs to be able to handle large-scale data sets. Monitoring and diagnosing is going to require working with some amount of data, and it's in that troubleshooting phase where the observability system should be able to handle unlimited amounts of data from logs, metrics, and traces. And this is a challenge for many observability solutions that don't have a high-end and highly scalable solution. Well, fortunately for you, built on a cloud-native architecture, Sumo Logic enables the ingestion and storage of any amount of data in a highly elastic and flexible way. Now, secondly, the observability solution needs to be able to have a very scalable analytics engine. Observability is going to require you to analyze lots of data to machine learning and other initiative search-driven analytic capabilities. Once again, fortunately for you, as a large-scale machine data analytics platform, Sumo Logic provides out-of-the-box capabilities to support the ingestion and analytics of any amount of data. And so that's what we're showing here is if you want to just do the what and just monitor your systems, you can do that. And you need a little bit of data, 20%. But as you want to get deeper and figure out the where and the why and the how, and those are really going to be the solving things, not just the what's, that's where you need more data and better use of tools and analytics. And we're going to show you some of those shortly. I got a couple more slides that kind of show similar things. Get a little repetitive here, but not too bad. So one aspect to achieve end-to-end reliability is going to be the unified observability platform. So what does that really mean? Well, another way of looking at it is this diagram here. On the left-hand side of the screen, what we're trying to show is the fact that it's going to be required to get all bits of data telemetry to perform the tasks that teams who are in charge of reliability and DevOps and DevSecOps from each and every layer that affects the application. So once again, getting all this data that might be coming from your hosts, your servers, your application components like database, cloud infrastructure, CI/CD pipeline, CND services, I can keep going. So it's required to have all that in Sumo Logic for visibility. And so this is going to allow you to monitor and then once again, diagnose and then get a little bit deeper with that troubleshooting. Now, once again, monitor, diagnose, troubleshooting, we're kind of drilling those into your head intentionally. And so want to talk about who can gain value from these utilizing these different features based on the team or the position. So for example, DevOps and SREs, those individuals that are responsible for monitoring the health of an application. Well, they're going to need observability so that they can quickly monitor and diagnose and troubleshoot application health issues. Observability is also going to help the software engineer on the team, or multiples, by providing visibility into the software pipeline. By collecting information about the pipeline and identifying issues with the software delivery process, teams can improve the quality as well as the delivery of their application. Observability can also help security teams ensure the security posture of their applications. What's unique about the Sumo Logic observability solution is that it addresses the needs of all these teams and personas in one integrated platform. All right, let's go. I'm going to probably skip this slide. It's once again kind of the same idea of monitoring, diagnosing, and troubleshooting. And what I'm trying to show in the middle portion here is surface level investigation opposed to, getting deeper into the investigation. So at the top, if we just want to monitor stuff as we've kind of described, it's pretty easy to do. You don't need much data. I can pretty easily make a chart or a graph type of thing, green, red, that shows this is good, this is bad. Might be, it could be any metric or measurement, but I can do that pretty easily. Now, as I want to get deeper into digging into the system, and typically that's going to occur during the diagnostic and troubleshooting steps, I need to get deeper into my environment, into my infrastructure. I need to go not just at the deployment level, but maybe look at the pod level, look at the component level, and then ultimately use some tools like Root Cause Explorer that we'll show you in a moment to start to troubleshoot. So this is a slide. What's our mouse doing? There we go. So this slide is showing some of the various advanced analytic capabilities that Sumo Logic offers, and not all of them by any means, but based on kind of this hierarchy of monitor, diagnose, troubleshoot, we can go ahead and see that kind of observability workflow. Today, we're really going to be focusing, for the most part, on the bottom right here of Root Cause Explorer. We're not really going to be using, well, I take that back. We're going to be using outlier analytics as part of Root Cause Explorer, but the other features we're just not going to be utilizing today. So they're great, they're helpful, just we have a lot of them and you don't need all of them. All right, I have this little quote here that I think is funny, or I guess funny, humorous, maybe a little dry, but what it says is we replaced our monolith with microservices so that every outage could be more like a murder mystery. And that's what observability gives us, whether it's Sumo logic or not, but the ability to no longer just go from staring at a server trying to figure out what went wrong, but using tools to figure out that, if you remember the kind of the old game Clue, that it was Professor Mustard and the observatory with the wrench, except this time we're going to want to see that it was a ELB issue affecting US East servers due to latency, or more valuable information, just of something that we might find on a board game, but we're going to start to be able to dig into that, and that's really helpful. It's really powerful. And you see this quote is, now I'm almost 7 years old and still completely relevant. All right, whoop, didn't mean to get a slideshow yet. Let's see, we've got about 5 more slides and then we'll get into the app. So we're getting there. So now I want to talk about Sumo Logic and AWS together. Why good? Well, AWS, first off, encourages the use of separate accounts to help manage costs and give teams independent administrative control. Additionally, different accounts often have different settings across regions depending on the need for a specific app. Once you're in a certain account and a region, then there's going to be a multitude of services that customers can use to run in their apps with each service. And so you have multiple entities or instances that correspond to it that then have their own data monitoring. The problem here is, with all this complex hierarchy, it often leaves vast data silos where it can be difficult to acquire a clear picture of overall AWS service health across regions and accounts. And so this is, as the slide is showing, the challenge. We see customers have multiple accounts across multiple regions with multiple services. And then how do you start to dig into that, get that visibility? Without that visibility, troubleshooting is complex. And I think you know that. That's probably why you're here. Now, fortunately for you, from complexity and chaos, we can go ahead and provide clarity and root cause. So with applications moving to the cloud at an ever-increasing rate, the new challenges in observability are presented as application architectures that inevitably have become more complex. These distributed systems are changing the landscape of effectively monitoring, troubleshooting, and securing your application. And so Sumo Logic's new, and it's been around for a little bit, but it's still new in the marketplace, the AWS Observability and Root Cause Explorer solution, break down these data silos and help us dramatically reduce the amount of time it takes to identify and troubleshoot issues with our application by giving us a better understanding of our AWS environment across multiple accounts and regions. So I'm going to show I think I'll show the slide. We're going to get into this as a tool in a moment, but just a high level of Root Cause Explorer, I think I'll just show here as a screenshot. So this is Root Cause Explorer. A lot going on, but a lot of good stuff going on. And we're going to do this, or get into this this portion of the system, like I said, in just a few moments, but just to give a screenshot of it. And we're actually going to start not in Root Cause Explorer, but what Root Cause Explorer is showing us, all these different events of interest, EOIs as we call them. They might be errors, they might be successes, they might be throughputs, they might be bottlenecks, they might be a variety of different golden signals, and we'll talk about golden signals in a little bit as well. But basically, the system is starting to identify that something abnormal, not necessarily bad, but abnormal, is occurring. And it's showing us these things. It's showing us these things based on color to identify event of interest. It's showing us based on time. So we can start to see this happen, this happened, this happened, this happened, and starting to see things that occurred. At the top, we're going to have filtering, which is going to make this screen a lot clearer, because right now we have a ton of different events. Well, what we're going to want to do is maybe just look at AWS events, or maybe just look at Kubernetes events, or depends on what we want to look at. And of course, for this class, we'll be looking at AWS information. The height or the y-axis here is going to be important. What that's showing is the drift, as we call it. And so what it's showing is essentially the deviation from the norm is probably the best way to explain it or say it. So a lower number means it's a little abnormal, but not too bad. Higher means, whoa, this is kind of really abnormal. And then what we'll see on the right is we can start to click on these little circles and dig into them and look at the specific metric and why the system considered it to be an error or a bottleneck or whatever it might be, and what was happening prior to help us identify why this occurred. So that's what we're going to get to. Certainly when we get an app, it'll be better experience than just a flat image, but the image should be kind of a good starting point. All right. Let's see, no questions yet. So let's go ahead and get into the labs. What we want to do is we want to welcome you as a new hire to TravelLogic. TravelLogic, as you might already know, is let's say, a production environment where users can go ahead and book travel, airfare, hotels, things like that. Now, first day on the job, we're going to be putting you to work. TravelLogic has mission-critical applications on AWS, and the application is using primarily 3 AWS servers: ELB, the Elastic Load Balancer, EC2, and DynamoDB. What we've been told, or what you've been told on your first day, is that travelers or end users are experiencing an outage in the application due to a 500 error occurring in the US East 1 region in the last 24 hours. Your challenge or job is now to troubleshoot the issue and isolate the root cause as quickly as possible. So how are we going to do this? We're on our first day at the job. Our manager comes to us and says, hey, Josh, check out the US East 1 region or area. There seems to be a lot of 500 errors. I need you to go figure it out and do your magic. We hired you. Well, show us what you can do. So I'm going to now use Sumo Logic to help me. What I have here on this next screen are some credentials we're going to go ahead and utilize today. I'm going to put them in the chat. The website we're going to use today is going to be service.sumologic.com. The email account we're going to use today is going to be training plus analyst number, and I want you to select a 3-digit number. Maybe you want to be training plus analyst 007, training plus analyst 391, training plus analyst 928. It doesn't matter. Pick a number. The password is Feb 2022 exclamation point. I know we're in March, but passwords get changed first Monday, so this password will be live for another few days here. So we'll go ahead and log in. Once you get logged in, if you could just tell me what number you're using. It doesn't really matter for overlap. It's just a good confirmation that you guys are hearing me and successful in getting in. As a reminder, you're going into a training account. Don't save anything you wouldn't want your manager to see. Not that we're going to, just it is a shared environment. If you can't log in or don't want to log in, that's fine. I'm still going to do the exercises on the screen, but certainly having you guys play along is probably more fun for all of us. Right. So I'm going to log in myself as well. So I'll do that on another score. I'll do that down here. So I'll do training plus analyst 234 at sumologic.com. And if you want to do 234 as well, that's fine also. And I'm going to use that password of Feb 2022 and put an exclamation point. Cool. All right, Naveen's in, so we're on our way. If somebody else could confirm, that would be good. But either way, I got some confirmation. So once you're logged in, and I'll still wait a moment or two, but for those of you that have logged in, you should be looking at a screen that looks pretty similar to what I have on mine. Now, it might not be. You might have some tabs that are showing up here. Go ahead and close these. These were done by somebody else, and so you don't need them, so go ahead and close them. You can also click on the 3 dots and choose to close all tabs. So ideally, you'll be on a screen that has nothing like this. So it looks like that. If you can't log in, try a different number. Try a different number series. Same password. It's possible somebody, somebody could have locked the account. So try another number series. And if you want to use my 234 as well, that's fine. That should work. So just tap dancing for a few moments here. If you've never been in Sumo before, feel free to kind of poke around. In here, you can learn more about Sumo Logic. We have a certification portal. All right, I think we're good. I see one individual is having problems. Yeah, we should try a different set of credentials and just double check that password. Right, but I think I think we're okay. Let's continue, and I can come back for people as well. So, but for those of you that logged in, let's kind of start to tell the story here. So I want to continue with our use case here. So what I want us to do now, is using these credentials, which we just did already. I want us to go to follow these steps. And I'm going to do them on my screen in just a moment, but I want to go to New, Explore, Explore by AWS Observability, and then pick my specific account. So let me do that because that's a little confusing if you've never been in before. Once you're on this home page, we're going to go to Plus New, and I want to go to Explore. I can also click on Explore here. I'm showing you the Plus New just because it has a few additional options that the icons here do not. So it's just a little more inclusive. And I'm going to, under Plus New, I'm choosing Explore. Now, when I go to Explore, I am in an observability view, but I might not be exploring AWS data by default. So this Explore by might be set to something else based on if somebody has previously used the account. So if it's set to anything else, we're going to want to set it to AWS Observability. So if it's set to Kubernetes or anything, go ahead and select AWS Observability. Once you've done so, what you should see on the right-hand side of the screen is your view into your AWS Observability. Now, this is showing a lot of different accounts. This is showing dev data, prod data, staging data. We have a mobile banking app that we use for another training class. So we have a lot of different instances, if you will, or accounts more specifically. Now, we want to choose a specific account. If you remember in the example I gave, we wanted to use prod US East 1. So what we want to do up here, I should just use one tab. Actually, we'll just use one tab, is, sorry, just making this a little less awkward. I think that's better. Okay, so what I want to do is I want to go to prod. Now, once I'm in prod, and I'm in those AWS accounts, as I mentioned earlier, you have that ability to choose region. Now, do you want to look at US East? Do you want to look at US West? Do you want to look at Asia Pac? Well, we want to look at US East 1. That's where we need to look at. So we want to select US East 1. When we click that option on the right-hand side of the screen, everything refreshes. And you'll also see, you may not see, it depends on how it shows, but you should have the ability to click on this down arrow for US East 1 to see all these different namespaces. What we're seeing here are the AWS services essentially that are running. ELB, there it is, ELB, Lambda, RDS, etc. And so now we're starting to get more information about our environment. Okay. Now, hopefully everybody's up to that step and can see that stuff. All right. Assuming everybody can, what I want to do is I want to go a little bit deeper into the system, because remember earlier I mentioned that there was an ELB, there might be an ELB, there's a 500 issue, let's say that, let's leave it at that. Now, what I'm going to do is I'm going to go to this application ELB namespace. When I do, it's going to load ELB information. Now, there is also another ELB down here. We want to use the application ELB. It's just a little bit different. But what we can start to see in here is information about, once again, our services, things that are taking place, specifically related to load balancing. But if I scroll down on this right-hand panel, what I want to point out, and what you should see as well, is this 5XX by load balancer. So 500 errors by load balancer. I also have a 400 errors by load balancer. You'll notice there are no take that back. There are no deviation in the 400 errors by load balancer. The line's pretty flat. There's errors, but they're consistent at least. Due to it being a training environment, the data replicates, and so we'd expect to see some consistency in that respect. Now, if we look on the right-hand side with the 500 load balancer errors, we see some spikes. I see one that occurred right here about 5 hours ago. I see another one that occurred probably about 17 hours ago. We have them repeat every 12 hours at 4 a.m. if you can get, or 4 o'clock. Actually, more closer about 4:40. What we can do here is we can click on this guy. Specifically, the spike is what I'm referring to as a guy. So we're going to click on that. When we do, on the right-hand side of the screen, we should now start to see some information. And so what we're seeing here is that spike. We're seeing and confirming it's US East 1. It's the 500 count. It's related to ELB, and so it's giving us that help of what's going on or what's going wrong. So what I wanted to show so far is that spike, and hopefully everyone got to it. And what we're now using is observability to observe a 500 error that's taking place in Sumo Logic. Now, I don't know what's causing it yet. We're getting there. That's going to be the next part of our exercises here, but that's what I wanted to show so far. And so hopefully everybody saw it. Hopefully you see how easy it is to access this stuff. More importantly, how easy it is to navigate through it, I guess is probably a better way to say it. And I'm going to continue with my deal here, but feel free to poke around in here. You know, if you want to go ahead and look at the dev stuff, you can. It's not going to break anything. All right, so we all found, let me go back to my slides. So we went to AWS Observability, we went to prod, US East 1, AWS application ELB namespace, and we found that spike that looked pretty similar to this. And so we, as I mentioned, we've observed the spike. All right, now, great to see the spike, really important, but that's not the most important thing. What caused the spike? That's really what we want to find out. Remember our iceberg slide, having this monitor or ping us that it was high or out of whack, that's not really that big a deal. Although it is, I mean, it's an important deal and many systems can't do that, but we can. But what we want to do now is figure out what caused it. That's going to be more important. And so now we're going to go ahead and start to dig into Root Cause Explorer. So what we're going to do now, still in Sumo, we're going to go back to the new plus sign, and we're going to go to root cause. When we go to root cause, we are now looking at Root Cause Explorer. It's going to take a moment to load. By default, it's going to load for the last 3 hours, and we will want a greater time period because that spike occurred about almost 6 hours now. But for now, this screen is fine just to talk about it. So once we're on the screen, we see for the last 3 hours, all these EOIs or events of interest. All right, what else do we see in here? We have our filtering, and we're going to use that in just a moment. By default, everything is enabled, so we're looking at all aspects of infrastructure in Sumo Logic. I guess that's an okay way to say it. But in this case, we don't really care about Kubernetes data. That's not today's presentation, so we can turn that off. We don't care about the application service information because that's a different lab. So we're going to go ahead and turn that off. And so what we're doing is we're starting to filter. Now, we will need a further time range, like I mentioned, but just before we do, we can start to see these EOIs. As mentioned, we can click on them, and on the right-hand side, we get more information about them if there's more information to show. So here, for example, I'm seeing a Lambda resource error that occurred about 40 minutes ago. If I mouse on it, I see contextual information about it, the drift, the duration, the metric itself. And then I also see here the metric represented by this dark blue line. And the system is showing me a time shift. So it's showing me yesterday the amount of errors it had. Now, there were errors yesterday, but it wasn't as dramatically high or peaked. And so that might be indicative of something. It might not be as well. Well, no, it's always going to be correlation to something. What I want to do now is I want to get that last 6 hours in. Cutting it kind of close, but it should be good enough. So I'm going to do last 6 hours. And when I do, once it refreshes, it might take a moment or two, especially if Well, either way, it might take a moment or two. What I want to focus on is this 4 o'clock, really this 4 to 5 o'clock time range. I can actually click and drag to zoom in if I want. Getting a little fancy, but that's all right. Fancy is kind of cool. And one thing I want to do here is, and I don't have to, but to just make it a little bit easier, is I want to select the region that's US East 1. It cleans it up a little bit. All right. So I'm now looking at the time range where there were 500 errors, and now I want to figure out or try to figure out why the 500 errors were occurring using Root Cause Explorer. So what are these guys showing me here? These two, they're overlapping. I think they're duplicates of them, but they're essentially the same thing. What I do when I click on them is I start to see a bottleneck was occurring. I see the metric, is showing a CPU load average. So what it's showing me is that there appears to be some sort of load spike occurring. Now, if I go right before that, what I should start to see is some issue of what occurred. When I mouse over it, I see it's related to the DynamoDB table. Remember, DynamoDB is one of those areas that I should be an expert in on my new job. I see it's related to the read throttle events. And if I click on it, I get the chart on the right. And what the right chart is showing me is the read throttle events is spiked. It normally goes up and down. That's not really surprising. But I see here in the green and the light blue what occurred yesterday and what occurred 7 days ago. And while it did go up and down, it didn't peak like this. And so the system is telling me, or I'm recognizing, I guess either way, that this spike is really weird. It's out of the ordinary. So something has occurred with my read throttle events. And so that's important. What I can then do is start to adjust that. Now, what we could do here, I don't think I have the data to show it. We used to get a little bit deeper in this lab, is that I could actually start to dig in, and I just don't think it's going to work, but I'll show you kind of what I can do, is I can start to dig into the logs, and I can actually start to try and figure out who has increased the read throttle events. Is it a person that upped it? Is it a CPU thing that's bumping it up? What kind of happened here? And so we're continuing to just dig deeper and deeper into the story. We're going from just the monitoring ability to now I'm looking at the service and I'm seeing it's related to components in DynamoDB or what have you. And once again, just starting to get deeper and dig deeper. And that's really what the power is of Sumo here. All right, so let me go ahead and jump back to my slides. Oh, I guess I'm actually in my slides already. Let me do a little summary here of what we just saw. I'm all the way behind. Sorry. We did that. We saw the root cause, saw the read throttle events. Oop, there we go. Sorry, summary. So RCE, or Root Cause Explorer, as we refer to, embodies, as it's chosen on the left-hand side of the screen, essentially 5 concepts. Abnormal spikes. Abnormality is always kind of an indicator of something. Typically underlying problems. It doesn't always have to be a problem. An abnormal spike can be a good thing. If it's sales data, a spike in sales data is good, but there's usually something to it. The context and correlation of those spikes is important. Did something occur a minute after something? Did it occur 10 minutes after? Those periods of times are going to be important to relate things together. The resources and the services, saying that something occurred in the ELB and also affected the DynamoDB is starting to bring a connection there. Those earlier spikes of seeing something happen, then something else happen. As we go further back, the first spike should start to get us closer to what was the cause. And then using the log exploration, we didn't go that deep into it with the actual root cause today, but we could start to go into those logs to start to see who was doing certain things. All right, so that's RCE in a nutshell. Hopefully that leaves a little bit of an impact. Want to go over another portion of the system while we still have time. Let's see. All right, cool. So we're losing Sam, but no problem. We'll catch him in the next one. I want to go over tracing and Sumo Logic Coffee app. So continuing with observability. Tracing is going to play a crucial role in tracking transactions of an app or anything, well, particularly an app, on a microservices-based architecture. So even a simple 3-tier application, and we're going to use Sumo Logic Coffee as our example, might require going through a load balancer, 2 servers, and a database. So there's going to be some layers there. Now let's introduce Sumo Logic Coffee. As you know, Sumo Logic Coffee has thousands of locations around the world, at least for today's topic. And our goal at Sumo Logic Coffee is to deliver a hot, fast cup of coffee. That's priority number 1. We've also expanded our menu to include pastries, which I don't think we're actually going to use the pastry example here for this lab, but as an FYI, we sell pastries now. And so imagine this company, very similar to a company that has a green logo worldwide, and we're using technology to sell coffee, which might sound counterintuitive. How are we going to use apps and architecture and technology, and we're talking about brewing cups of coffee? Well, let's see. This is what a successful order at Sumo Logic Coffee looks like. The customer is going to place their order. They're going to place it on an app. And once again, I don't think we're actually going to use the app today. That's another class we have, but you would have a little app. You order your pastry, you order your Americano or espresso or whatever, you place your order. That order is going to need to get to somebody, because somebody's going to need to do the work. And so that barista, that employee of Sumo Logic Coffee, is going to get that order. He is, or she, they're going to initiate the coffee machine. The coffee machine is really going to do most of the work here. The machine is going to make sure that it has the adequate amount of level of beans. If it has those beans, it's going to grind the beans. It's going to make sure it has an adequate level of water. If it has enough water, it's going to add the water. Water, beans, magic occurs, and then the coffee is ready for the customer. Now at Sumo Logic Coffee, we are a profit organization. We are not giving free cups of coffee. And so the customer does need to pay for the order. The credit card is going to be approved, assuming credit transactions. And then customer picks up their order. And then a hot cup of coffee has quickly been delivered. So in that regard, each step is like a microservice, exactly as it says there. Now to go a little bit deeper in the microservices review, what I just outlined and what occurs in a coffee order is what we're seeing on the screen. So in our prior example, we focused on the web app, but what we're going to do now is look at use the idea of Sumo Logic Coffee and the idea that there's going to be a machine service and a payment system. The machine service is going to be made up of the coffee service and the water service, which are going to be made up of getting the ingredients and making sure there's enough of them and then adding up. The payment system, once again, we charge for our coffee. How much is each order? How many orders did they make? 2 cups of coffee versus 2 pastries, different pricing, and that all needs to be calculated. So what I want to show first, before we actually get into tracing, is service maps. What service maps are going to be, as it says here, is a high-level view of application environment. In fact, let me see. Here's a better picture of what they look like. So what this is going to allow us to do is, like we saw with Root Cause Explorer, essentially in real time, see traces occurring and see where things are starting, where they're going, where there's issues. So for example, on this screen, and I'm going to jump into the system right now. In fact, I am going to do it in the system right now, and I hope you join me. I'm going to go to plus new at the top. And this time I'm going to go to service map. Now, what I see in this service map are going to be various applications that exist within our account. Now, in our account today, on the far right, we're going to be talking about that coffee bar app, the one that has a lot of red. We also see on the far left a payment service. Now, this is just because we're in a training environment. We have a few different apps. Go ahead and select the coffee bar app from the application name, just so we focus on that one. And now we're starting to see activity as well as anomalies that are occurring. Red is representing anomalies. So here I see the coffee bar. Here I see the coffee machine. The coffee machine has machine services. Machine services consist of coffee and water. Those are red. Red's not good. And so we want to kind of start to dig into that. But that's what we're seeing at a high level overview. This service map is dynamic, so it's going to adjust in real time. We can also click on these bubbles and zoom in on the right-hand side of the screen as well. So we can start to get some context to what's occurring, seeing latency. When we click on it, or even if we just hover over it, we see what is red as far as what's the issue here. In this case, it's latency. Not really errors, but just a lot of latency. And so that's going to be helpful for us. We also have some settings in here. I'm not going to really go too deep into them, but we can go ahead and start to adjust how the anomalies are detected. So if you've used Outlier with us before, which is a really powerful operator within Sumo, you can go ahead and adjust that calculation. The default's pretty good, but you can modify it if you wanted to. All right, so that's service maps in a nutshell. Pretty quick, pretty easy, pretty illustrative, pretty. All right, now we're going to get a little deeper and go into traces and spans. Traces is the main focus, but I'll point out spans. It's a new feature as well. So, all right, so let's start these because we should be okay on time. What I want us to do here is I want to go through the traces, what they are, and more importantly, how to use them with a specific example. So while I do have some slides, I think I'm just going to go through this with you. Let me think about this. Yeah. What I'm going to do here is go ahead and open, new traces. So far we've done new, what we've done? We've done explore, we did root cause. We'll probably do spans in a moment. We did service map. We want to do traces now. Now, traces are essentially transactions. When somebody places an order for coffee, that's a transaction. It becomes a trace and it gets an ID. Now, with that trace, what we're going to be able to do is start to look at that order, that transaction in depth, and start to see where things might have gone wrong. So let me go ahead. Actually, maybe the slides are helpful here. So we'll do this in a moment. We just did new traces. We're going to modify the screen in a moment. But what we're seeing here is like what I see on this screen. A little bit different in yours, but basically the same idea. We have the trace IDs, which is that order number, essentially. A little more complicated, but basically that's what it is. We have the when it started. When did the order come in? The duration. How long did that order take? Remember, it's important for us to deliver a hot, fast cup of coffee, so speed is important to us. We see status. It's actually going to be represented a little bit different on your screen, but it's going to give us an indication of was the transaction successful or not. Ideally, all of them are successful, but sometimes they're not. What we're going to do and what we're going to show right here is a trace from viewing it as a trace ID. So what I've done on this screen is I've looked at a good order or a successful order represented by a 200, meaning it's good, it's okay, that's the status code here. So what I see when I see a good order is what it looks like right here. What I don't see is a lot of red. So in a bad order, like in this one at the bottom where it's a 503, I see a lot of red. Green good, red bad. Kind of oversimplifying it, but that's okay. Now, seeing the green is successful, that's not really that helpful. It is, don't get me wrong, it means we made money and things are working properly, but the red is where we want to dig in and try to figure out what went wrong. So once again, a successful order. And as you see with the successful order, you see various components of the order process. You see the green, the cash desk that's responsible for the payment process. You see the machine service, the coffee machine that's responsible for actually doing the work, and et cetera. All right. And what we're going to do with the spans, I'll go through these slides, then we'll do the walkthrough of both. Spans allow us to filter, as it says right here, I don't intentionally mean to read it, but what spans allow us to do is perform an advanced, flexible, ad hoc query analyst for application level data. It's going to allow us to filter and aggregate using standard custom span attributes like tags, almost like metadata. And so it's going to allow us to quickly utilize these, and we'll see how it takes advantage of this SQL or the search query language. So we'll see these in a moment. But what it's you're going to go, and we'll do these together. We'll go to the new span, and then we're going to have the ability to start to filter. And then we're going to have the ability to start to use what we call facets, which are like these metadata tags or attributes that we can then filter on. So it's another way of filtering. So let's go ahead and go through this. I kind of probably went a touch too fast through that, but because I wanted to get the hands-on experience, because that's better. So hopefully we're still logged into Sumo. We shouldn't be timed out. What I want us to do first is go into the plus new service map and just like I says right here, basically just kind of play along, if you will. Okay. Now what I want to do next, and I'm crossing my fingers that this works. It worked earlier, so I'm a little nervous, but it should, is I want to go ahead and locate the coffee service. So what I'm going to do here is I'm going to go back to my service map. I'm going to go to my coffee service and I'm going to click on it. And then what I'm going to do is I'm going to go open in and I'm going to select traces. By doing so, what should occur is I'm now looking at my traces, but now I'm looking at specific traces. I'm looking at Coffee Bar app, but specifically the coffee service. I could also do this for the water service, but I want to show the coffee service first. So now I'm kind of pausing here just to make sure we're all together. I think we're pretty good. So we see a bunch of traces in here. And we know some of these traces or transactions went wrong or went bad. What I want to do now is I want to select one that went bad. There's the number of errors here. It should not, let me check before I say this. Yeah, it should not matter which one you select. So you should be able to select any of these traces that have errors. Now we want to figure out what those errors mean. I'm pointing you to one that has an error, but now let's go ahead and figure out what the error means. We know there's a problem with the coffee service. We know there's a problem with this specific order with the coffee service. What is the specific issue? Specific. Remember, not just saying what went wrong, but where, how, why. So we're going to go ahead and look at that. Now, what I want to focus on is these red lines, and specifically the lowest red line here. Now, it's a little hard to see because it does zoom in automatically. I'm going to zoom out. Actually, I'm going to zoom in because I'm looking for this little guy here. So there should be a line at the very bottom next to the blue one that's brown. I don't know, it's a very ugly color, but it has a little red line. I'm going to click on it. And specifically, it should be the coffee service. Now, when I click on it, on the right-hand side of the screen, it's going to give me more information. So it's giving me that context. As we've seen earlier, it's going to give me some charts, give me some other stuff, helping me identify where this stuff is located. And what I want to see, or what I hope to see here, is what caused this error. There was an issue with the coffee service, specifically getting beans. What's the problem? How do I get that fixed? Let's find out. What I'm going to do here is I'm going to look at the logs, because the logs are going to tell me what occurred. I'm going to choose the span ID. I could choose the trace ID. It's just kind of overkill. It's going to show the whole transaction. In this case, I want to zoom in on just the part that went wrong. So I'm going to click on the logs in the first line. And when it loads, it might take a moment or two, but when it does, it's going to give me 2 lines of code. So I'm just going to wait. I have them up there, but making sure you get your 2 lines of code. And what I'm going to do is read the bottom to the top. They're in chronological order. So what happened with this order? Info, received order for coffee greens. So the system received the order and it needs coffee. What's the problem? Lack of coffee grains. So very simply, for this order, it failed because there was not enough coffee grains in the system. Now, what do we do about that? Well, many things. We might train our baristas to fill the coffee hopper, or the bean hopper, more frequently. Maybe we put a bigger reservoir on the bean hopper so it holds 4 times as much beans, or, there's many actions we can take, but that's what we're seeing in here. And so now we can start to see here what caused the issue. We can also get a little bit deeper. We're not going to, but we could start to figure out how many orders are being impacted by this. All these are affected. Well, what percentage of these are impacted by the bean hopper? If it's 0.001% of our orders, maybe we don't care too much. If it's 5%, maybe we do. And once again, just making those decisions, or relying on somebody in our organization to make those decisions. So hopefully that was a good use of tracing. I thought it was, but hopefully you got to see the problem in there. All right, let's see. I think we're just about done here. Let's let's see. Let's hit back the slides, and I think we're in the home stretch. So let's see. So we did this service map to the trace view. Then we opened traces. We did all these steps already. We looked at that lowest level. We looked at that summary. And then we looked at the logs, excuse me. Oh, span analytics, we didn't really look at. Let's see, do we have a good example for span analytics? Yes, what we can do here is if I go back to my trace ID, let me see if this works, it should. And what I want here is I want actually the span ID. So I'm gonna go ahead and copy the span ID. So inside the quotes, or one quote, I'm gonna grab that span ID. What I'm gonna do now is I'm gonna go to plus new, and I'm gonna go to spans. And what should happen, so just pasting that in should filter. Let's see if we can find it. Oh, actually what in my filter, I should do, where is it? Span ID, sorry. So I should do span ID equals that that ID number. Let's see, this is pulled back. Okay, cool. And so what this is starting to let me see is the span. It's just another way of looking at things, really. It's not, I guess, very unique. But it's let me look at that specific span. So I'm seeing the span. I'm seeing it has an error. Remember when we looked at it from this view, the status is okay, but there are errors. And so in the span view, it's actually identifying that it had an error. It's also going to let me utilize these facets, and it's really metadata tags essentially, but we could go start to utilize these to provide us with more information. So let's see, which one would be helpful here? I don't know, service name. Well, we already knew it was coffee service. Let's see what else might be helpful here. I don't know, these are probably that great. I guess the application is also going to be coffee service. Yeah, coffee bar app, but we can start to get more information. And so we can use the metadata here to start to essentially create a query and start to create a query builder from this. So just another way to get, like I said, more info, a lot of different ways in Sumo. All right, let's wrap this up here. So let me just point out one more thing, is unified alerting. Probably should have a lab for it because it's important. Probably not but it's not the most important thing for today. But what I did want to show you, especially if you haven't used Sumo in a while, is there's now a unified alerting environment. So previously, when you wanted to create an alert, it was kind of cumbersome. You'd have to create a query, you'd have to save the alert. If you wanted to modify alert, you have to go back to that query. Now everything is all in one space. And so you can start to create alerts, whether they're log or metrics alerts, that have specific kind of levels of when they trigger, who they trigger to, a severity level, is it severe, is it critical, is it a warning, and just better capability. So if you haven't used Sumo before, this unified alerting is going to seem obvious that it should be there. If you have, you're going to be happy that it is there because it's been needed for a while. So just wanted to remind you of it. Summary and next steps. The next step, summary we can skip over, but next steps, I'll go ahead and put some of these links in the chat just to get to different areas of Sumo Logic help to just to get more information. What else? And then finally, I would just remind you, if you're interested in more trainings, to come to our website and join us. So there we offer a variety of different trainings that are free. Usually certification related. So you can take your certification, your exam, and pass and get credit for an exam and get a certificate, which is kind of cool. let's see, that's really going to conclude today. So thank you everybody for attending. Glad we had a pretty good group, good size. So that's always good to see. And you guys had some good questions, which was always fun as well. So go back, give you 4 minutes of time. I'll be here for a moment or two if there's questions, but other than that, thank you for attending. Hopefully you learned a little bit more about Sumo Logic. And if you have any questions, just reach out to us. Let me go ahead. That last link didn't paste in correctly. So let me just edit that real fast. There we go. So cool. So thanks all, and enjoy the rest of your day.